Hi everyone, here's a presentation of Network Science and Application Project. My name is Li Wang. I'm now a graduate student in Electrical and Computer Engineering Department in University of Florida. The name of my project is Grammar Parser. Here is the outline for today's presentation. It includes 4 parts, which are background, algorithm for grammar parser, results and analysis for this project, and finally is the conclusion part. First of all, let's come into the background part. Here I will talk something about the semantic network, the relationship between semantic analysis and syntactic parsing, and the grammar parser in this project. Semantic network is a network that represents semantic relations between concepts. It is often used as a form of knowledge representation. It is a directed or undirected graph consisting of vertices and edges. They are represented by connected nodes and arcs. In order to construct or analyze semantic network, we should have a good knowledge of both semantic analysis and syntactic parsing. There are 2 important elements in the field of semantic network. They are highly related to each other. Semantic analysis cannot get good results without syntactic parsing, and syntactic parsing has no meaning if it just gives the structure of all the sentences. The final goal is to make them cooperate with each other. So my main work in this project is to work on the grammar parser. Now let's come into the second part of my presentation, algorithm for grammar parser. The tool I used to implement this programmer parser is Prolog. It is a new language for me to learn. It's really a powerful tool to be used in the field of natural language processing. One reason is that the programming syntax and the language itself is straightforward. It is easy to get hands-on experience comparing with other kind of programming languages. The other reason is that it has built-in functions for grammar parsing. It is born to work on linguistic words and serve for natural language processing. The language to be parsed in this project is English, and the input for the grammar parser are English sentences. There are grammar rules and lexicons. These 2 are important parts for grammar parser in my project. Here are some of the grammar rules I implemented in my program. We can take the first one for example to explain. S here means sentence, NP here means noun phrase, VP here means verb phrase. The first rule here means that S consists of NP and VP. And VP here can be in the tense of present and past. Here is a sample of lexicons for my program. We can take the last one for example. Here is the word want. It is in the category of verb. The root form for this word is want. The verb form of this word here is in its base form, and NP and VP can be the subcategory of this word. Okay, this is the lexicons for my program, and this is a brief view of the grammar parser in my project. Next, let's come into the third part of my presentation, result and analysis of my program. There are 2 parts of testing. One is the initial version of my grammar parser. It can only take some of the simple sentences. And for the second part, it can take input with more complex sentences. Here is the test results for the initial simple version of my program. I only list 2 test cases here. One is that the input is the word list of the sentence. Here, the input is the man cries, and the output will be the tree structure of the input sentences. Here we can see that the structure of the input can be that it is composed by verb phrase and noun phrase and verb phrase, and the noun phrase is composed by article and noun. Furthermore, there's another test case for my program. The input here is he wants to be happy, and here is the output of my program. The output of the grammar parser tells that it is in the present form and a third person singular, and the result tree structure shows in the last line of the output here. And here is the second part of the grammar parser. As a function to parse passive sentences, and it can also deal with WH questions. Here's the test result of sentence "the pizza can be eaten," and it is in the passive form. And here's another test case for the second part of my grammar parser. The input is a WH question is who sings the song, and here's also give the tree structure of the input sentence. Okay, that's all for the test result of my grammar parser. The input of it is the English sentence, and the output is the tree structure of the input sentence. There are many test cases. Here I only list 4 of them. Finally, let's come into the conclusion part. In this project, I implement a grammar parser using Prolog with grammar rules and lexicons. But for the reason that there are that many grammar rules and lexicons, I cannot implement all of them in such a short time. Therefore, for future work, I can add more grammar rules and lexicons to enrich my grammar parser. What I learned from this project is that I got a relatively deeper understanding of semantic network and especially grammar parsing than before. I found that there are a lot of fronts deal with the language we are using every day, and it is amazing to build a grammar parser by myself using a new programming language for me, that is Prolog. Okay, this is all for my project presentation. Thank you. And next, I'll give a demonstration of my program. My program is represented here. There are 2 .pl files. It is in the form of Prolog. Here is the software for Prolog. First of all, I need to consult the files. Wait a minute. I need to consult 2 files. One is this, and I'll consult another file, this one. For inputs, for the reason that the input is so long, I just paste here for simple. Paste here. This is the input of the program. We can see that the input here is the man cries. I just press enter, and then it will show the output. Here is a tree structure for this sentence. The noun phrase, verb phrase, and noun phrase is composed by article and noun. I can input another test case. Also, I'll paste it here instead of just typing and press enter. Here's the result for the passing. The input is he wants to be happy, and the output is the tree structure for this sentence. Okay, this is a demonstration of my program, and that's all for my project Grammar Parser. Thank you for your attention.